The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everyone, and welcome to today's forum. My name is Anton Delport, and I'm an industry specialist at Esri Australia, and will be hosting today's session. Before we get started, I want to let you know the session is being recorded, and you will receive a link to the recording next week so you can watch or share with other members of your team who are not able to join us today. We encourage you to submit questions throughout the session. There is a GoToWebinar question panel on the right-hand side that you can use at any time during the presentation. And we've set aside some time at the end to answer any questions that you might have. So let's get started with today's session, building smart infrastructure with Autodesk ArcGIS integration. So joining us today, we welcome Stephan Gumpert, who leads Autodesk's APAC Buildings and Engineering Technical team. Stephan helps businesses streamline workflows and improve project outcomes using BIM processes and Autodesk cloud products. Today, he'll be sharing how Autodesk solutions such as Autodesk Infraworks and Civil 3D integrate with ArcGIS Online and demonstrate cloud-based data sharing workflows for BIM and GIS teams. Also joining us today is Senior Consultant Seth Gorrie from Esri Australia. Seth advises on best practice solutions across multiple industries and will be sharing some very interesting use cases in his presentation. He'll also give us a quick look at Arcgis Geo Bim, Esri's new cloud-based integration solution. I'll hand over to Stephan now to take us through the first part of his presentation. Thanks, Stephan.
Thank you, Anton. Okay, can everyone see my screen okay? Yep. Okay, I'm going to assume that's awesome. Okay. Yeah, welcome everybody. Today's session, we're going to talk about building, I guess, smarter infrastructure. Or the phrase I like to use is working smarter, not harder. So as introduced, my name's Stephan Gumpert. I am a technical specialist in ANZ. The process that we're going to go through today is just start with a brief introduction, look at the Autodesk and Esri partnership, and then see how that partnership influences the use of the design tools that Autodesk is so commonly known for. In this case, it's Infraworks and Civil 3D. Before we start though, BIM is that foundation for digital transformation. Being able to evaluate, design, plan, build, and operate your asset, BIM is one of those things that helps make that easier. But this is not a linear process, more of a circular process in that, we evaluate, design, build, and operate, but then monitor. And if required, the asset needs to be reassessed and redesigned, hence the reason why it's a circular process. Just a little bit of background on Autodesk. We don't just play in the AEC market, although we are quite strong in this space as well. We also operate in the manufacturing space, and a lot of the movies, media entertainment you see today are made with Autodesk software. So it's quite interesting to see where we are in the market. But if we switch back and have a look at the industry for a second, it is estimated that we're going to have to build around 13,000 buildings per day and enough road and rail to wrap around the earth 30 times every year to keep up with the demand between now and 2050. Technology is essentially disrupting the way we deliver projects, and it has been for decades, right? 35 years ago, Autodesk introduced AutoCAD and started creating software tools to help people with project delivery challenges focused on automating of the drawing production side of things. Then later on, say early 2000s, you know, the introduction came of 3D modeling, or BIM as we know it today, or BIM-based design. And not only did this enable 3D design, but it brought about a concept of intelligence in the model, where components in our model were intelligent, had information attached, like doors, windows, utility poles, roadway center lines, etc. And then if you look at today, we're developing tools that are cloud-based. So incorporating together BIM and the cloud, we get what we would refer to as connected BIM, which gives AEC professionals the tools to collaborate better, visualize, manage, and use their data in a more holistic approach. It also streamlines the process for integrating location intelligence with infrastructure project delivery. If we look at the future though, tomorrow, who knows what the technologies will be, but I'm sure there will be plenty of other technologies which will continue to disrupt what we do. This is important because if we think about the demand that we need to deliver by 2050, more is inevitable. The demand of more is driven by demographic changes that are already underway. Our customers, and I'm sure your customers, are starting to want more in the way of access to this information that produces these 2D drawings that we so love today. Let's be realistic. Information is king these days. Let's take the likes of Google and Facebook. They are awesome at what they do in the way of advertising because of the way they utilize the information. And you know, we see technological change where this information is more and more accessible to us just at the click of our fingertips. But how are we going to use or utilize this change, right? So with new technology comes new opportunities to do better. I mean, it's no secret, Autodesk creates software to help customers do more. The developments in software have identified new opportunities where we can do things that we couldn't do in the past, right? And thinking about all the products in the AEC collection that exists today, products like AutoCAD, which is a real household name these days, you know, the connection between these products is the key to linking that data from one product to the next. For example, the exchange of information from Infraworks to Civil 3D or Civil 3D back to Infraworks, you know, with all this being part of that AEC collection. But we needed to do more in the infrastructure space. Hence, what did we do? Well, we created a partnership with Esri, and this partnership was announced back in 2017. So a lot of people ask, well, why did we do this? If we take one example of why we might have done this, right? Go back to some common challenges that we may have encountered in obtaining existing utility information. In this example, you can see the current set of information that we currently receive about existing asset, right? So in the image, here's a key plan with some dial before you dig information. It came as a PDF. It had a scale bar, north symbol, the legend. Not exactly detailed, but it's something that gives me an idea of where this asset is. Survey teams spend copious amounts of time and effort locating these services, you know, out on site with inaccurate information to go off. Now, it's not impossible, but it is time consuming. So if you can see in sheet number 3 here of the key plan, you can see that at least we have the street information in this particular image, which again gives us something to reference to finding that asset. But if we go and look at sheet number 5 that was delivered, you can see in this case, very little asset information. And you would require some really complex interpretation and understanding to go and locate these assets in this case. There needs to be a better way, something more efficient to be able to share information across the teams. The opportunity to improve the way our customers work and, let's say, reduce the inefficiencies was a key driver in bringing this partnership together. In all industries, right, removing silos is key, but removing those silos between GIS and design teams meant that we created connected workflows to reduce risk, reduce the inefficiencies, data loss, and ultimately cycle times. The demand for new buildings and infrastructure to be built by 2050 is just one of those things that is driving integrated BIM and GIS workflow development. I mean, the AEC industry is currently in a state of advancement and change, and I see this firsthand every day. Technology is influencing every part of the way projects are being designed, delivered, built, and operated. And BIM standards and processes are increasingly becoming a requirement for working on these projects, especially as they get larger and more complex. And these mandates for BIM-based processes aren't necessarily always from company level, but they also exist at a government level. So bottom line, we need that centralized data so that, you know, we can share the information easily and make it accessible to everyone. What I'm really excited about is the I in both BIM and GIS, that information component. Fundamentally, the message is we want to start by putting the data at the center. Again, think back at Facebook, at Google. How do they attack the advertising? It's everything that they know about us allows them to target the advertising the way they want to get the best result. If we're able to understand all that information about that asset before we start, we can make better decisions and end up with a better outcome. Or, as I said in the beginning, lets us work smarter, not harder. But the new way of working with GIS and BIM project data, information is transparent, trackable, and reliable. The users can pull the information into their Autodesk design tools through the use of connectors that have been developed between this relationship, right? The information is live, rich, and full of attributed data that can be pulled into our design applications as opposed to just receiving lines, points, polygons from those traditional shapefiles. If GIS data gets updated, it can be quickly refreshed in the Autodesk design tools. This enables design and construction teams to work in confidence that they're using the same latest rich data that they're expecting. And when changes are made by the Autodesk design tools, they can be published straight back to Esri for future consumption. Once the construction of that asset is complete, as-built information is published back into the system for handover for use through operations and maintenance. Obviously, this data is useful through every aspect. Once the asset is in operation, this data-rich as-built information can be continuously referred to and used for the duration of that asset's life. Now, when it comes time to, let's say, updating that existing asset, think of widening a road, putting in a new pipe network underground, whatever it may be. That new design team can reuse that existing information that is accurate and data-rich from that as-built state prior with confidence, rather than having inaccurate, untrustworthy data, similar to the examples of, or some of the examples that I showed earlier from that dial before you dig information. Thinking about that widening of that road or that asset that we want to update, right? We may have a look at, scanning point cloud information, bringing that point cloud information into Infraworks, attached to some other information that we've pulled in previously about the existing road network. We may choose to share that data between Infraworks and Civil 3D, or even with Revit. So if there's a building involved and the infrastructure that we're designing is around a new structure or an existing structure, we may need to share that information with the design team in that Revit space. Ultimately though, they can all be working in the cloud, which again makes that connected workflow good. Coming back to the partnership though, at both the Infraworks phase and the Civil 3D phase, we're able to bring in that existing as-built information from the ArcGIS platform. As I said, we want to make smarter decisions for better outcomes and break down those silos of information. The combination and interoperability of BIM and GIS information will improve not only your experience, but will also improve your customer's experience and the way the project is delivered as well. So to put it in some sort of a diagram to show you the exchange of information, you can see here the information can be pushed and pulled into Infraworks and of course from Civil 3D as well. But don't forget that because of our design applications, we can share information between those environments as well. Now, if we take that Civil 3D data and we share it to Revit, or we share it to Infraworks, or we pull in point cloud information, to be able to share this information, we need to make sure we specify where this data is captured and utilized from. And it's a little bit like the whole where's Wally type thing, but in each one of our applications, you have the ability to define that coordinate system so that when you do share that information from one platform to the next, you're able to then export that shared coordinate system, for example, to Revit to be able to go to that next step. So let's look at the Infraworks component of what we're talking about here today. So as I said, what does this look like in our software? Well, Infraworks is the starting point when working with that GIS data. Infraworks can handle multiple file formats, which makes it incredibly flexible for planning and design teams who may be using information from a wide range of different softwares. And you can see the list there on the left. As you can see by the blue arrows, the information flows in both directions, all across the system, right? Also worth mentioning is that the entire way of working can be hosted in the cloud. Again, enabling teams to access information across larger geos or even countries in some cases to access information quickly and easily and having only one single source of truth. So let's have a look at an example of this today. So in Infraworks, I'm going to connect to my ArcGIS platform, go and have a look at my content for the area that I've highlighted. In this particular case, I'm bringing in a sewer example, and I want to map these new features to a feature with inside of Infraworks. So the pipes will come in as a pipe feature, and the structures will come in as the structures inside of Infraworks as well. So the system pulls down that information, loads it directly, maps it to the data sources accordingly, and once it comes in, we need to preview the data or go and have a look at the information so that we can see what it actually looks like. So we'll switch to a engineering view where we can see more information, and then we're going to go and modify the features that we've just brought in to utilize some of that data that has come in from that platform. So the pipe invert levels, we set it to the start invert and the end invert, which is properties that has come in from the ArcGIS system. We also bring in the inside diameter for the size of the pipe and also give it a display type so that we can represent the information accordingly. So in this case, all my pipes will be yellow. Again, we refresh the information, the model will re-display itself. You can see it's quite quick and efficient inside this environment. In fact, I describe Infraworks sometimes to people as a little bit of a gaming environment because it's quite efficient in the way it displays its information. We're going to go to the structures component, which is the junction points at each of the pipes. Again, we're going to give them a display matching that yellow color so that we can see it. We then go and put in the size of the manholes for each one of those junctions, and also adjust the elevation to match the depth of where this intersection is. Now again, once we've done this, we go and hit the close and refresh button. The system closes and refreshes, and again you'll start to see the information display on the screen. And you can see that, there you go, here's the refresh. Once it comes in, you can see this information is in context of where that was according to that data that I pulled in from the ArcGIS platform. If I select one of those elements, you can see those ArcGIS properties exist in Infraworks as well, which means you can go and look and see where this attributed information is. Again, information is king, right? So let's have a look at the Civil 3D side of things. Again, it is a bidirectional flow, but in this case, we are going to pull information from ArcGIS itself. Again, we open up, we look at the area in context that we want to have a look at the content that's available in that space. We go, and this time, instead of mapping feature for feature, we actually take the elements, and so we're going to map the pipes and the structures to our gravity pipes and gravity structures, so that you've got native Civil 3D objects inside of your design model. In this particular case, we're going to map, again, the properties that have come in from ArcGIS into Civil 3D to properties that will be used to model those components. So again, the start and end elevation, invert level of the pipes, diameter, and so on and so forth. And when we're finished, you'll see that, again, we've got those elements modeled in space as native objects. And when you go and look at the structural, the properties of these elements, the data that is mapped, and of course the data from Civil 3D, can be seen in those elements themselves. Whether it's, in this case, the manholes or the pipes, you still end up with the same data that was brought in. Obviously now I can manipulate that data and then ultimately want to push that information back again. So keeping in mind though that we can always visualize the data or transfer the data between the two applications as well. When I finish the design in Civil 3D, I can actually publish it back for visualization inside of Infraworks. Or, as I said in the beginning, you may choose to toy around with the concept design in Infraworks to quickly manipulate something, to then push that concept design to Civil 3D. So the key element or takeaway is interoperability, right? And again, working in the cloud means it doesn't matter where you're located, you can share that information easily across the teams. So what about if I want to publish the information back again? As we said, when we finish with the as-built, we want to share that information back with everyone in the environment. So we come in and we can define some new property sets, right? So we give this property set a name. In this case, it's called Proposed Manholes, created by one of my wonderful colleagues in the US. We create a handful of properties that we want to apply to these manholes. So in this case, we've got installed by, installed date, and the third one was asset condition, of course. So, you know, we sit down and choose which type of element we want to apply that to, hit apply and OK. And now we can go through and select those elements that we've got modeled in our environment and go and modify those properties. So if we select a handful of these manholes, go to the properties of these elements, make available only the property sets that I want to have a look at in this particular case for these objects. So I'll come in and look at my proposed manholes property set, and you can see because they're common across all those elements, I can go and start putting this information in. And you know, these manholes were created in 1998, right? So a long time ago. Again, once you've applied that information, you can see we click on one of those elements, go and look at the properties, and you can see the information is there for viewing in the model. Now, the important part is when you're finished, we do have the ability to publish this information back again. So being able to come in follow a specific workflow, select the particular information that you want to send back, choosing the area inside of ArcGIS where you want to publish it to, assigning the layer name for your data, and then, of course, once you hit publish, the system will then go and add this information for future teams to then go and reuse. And this is important information because, as I said, this is the whole cyclic motion of being able to share the data from beginning to end and then reuse again at that later stage. So here you can see, scroll down, there's those particular bits of information that we showed you earlier before that we created in our design environment. So as we've shown today, the ability to share across all our applications backwards and forwards with the ArcGIS in mind, right? Keeping the data at the center gives you more centralized approach to that design, plan, build, operate concept. Big question is, how will you utilize this data on your next project, right? So how do you plan to use this if you haven't done this before, or contribute to that asset for that next evolution of that asset? And how are you going to change your approach to enhance not only your experience, but your customer's experience in the consumption of that in BIM and GIS? Ultimately, there's lots of different benefits to going down this connected workflow experience. Everything from the reduced time for delivery, better communication, and obviously reducing the risks. Anyway, hopefully that was some insight. Again, if you are interested in answering or asking more questions, please go into the Q&A box and ask your questions as you feel.
Terrific, thank you, Stephan. I must say the partnership between Autodesk and Esri has been a fantastic development in my view, and we're really looking forward to what it's going to produce, and it has, even over the last 3 years, produced a lot, I know, in our various technologies. Before I hand it over again, another reminder to ask your questions. We do have questions coming through, and we will get to those very, very shortly. So I will now hand over to Seth to show us some real world examples. So thank you, Seth.
Thank you, Anton. Imagine that you manage an asset in a complex natural or urban environment, and now manage needing to implement change in that environment. As you can see, the coordination that it took to demolish and construct this development in the CBD of Sydney required more than just information about the existing infrastructure. It also required information about planning controls, including heritage overlays, noise restrictions, and traffic volumes surrounding the site, and many more aspects beyond the proposed infrastructure. What we see is that BIM supplies detailed content about assets, whereas GIS typically provides information about assets in the context of the built and natural environment around them. When we consider this content and context at site, suburb, or even state scales, the value of tying together BIM and GIS becomes more evident, as we can now start to ask and answer 4 common questions about change in the world around us. Where is the asset change being implemented? What is involved in the change? What assets are changing? And at what time scale or time increment is the change required? Unfortunately, bringing CAD, BIM, and GIS together isn't always easy, and this results in data and information loss throughout the project lifecycle. In many organizations, different types of data are siloed in disconnected environments. As a project moves through each phase, data can be created and stored in one particular system, but the data isn't readily available or accessible in the next phase. This results in workflow inefficiencies, data duplication, rework, and higher costs throughout the asset's lifecycle. But by integrating GIS and BIM workflows, we can minimize the inefficiencies and information loss smoothing out that curve. With proper integration, each project phase can leverage and build on earlier data, which creates a clearer and more complete picture of the project as it progresses. So what else is driving this change? There are a variety of other business drivers for BIM and GIS integration beyond reducing this information loss I just mentioned. Often these integration efforts involve customization or extension of existing BIM and GIS capabilities that you all have. But however, this development is quite costly as far as an integration activity. Customers are asking us, both Autodesk and Esri, and wanting to integrate and improve project efficiency in the construction process by decreasing risk and increasing visibility of compliance issues throughout each of those 4 key phases. So we believe a better way to work is to help manage your project at every stage, both with ArcGIS by Esri and Autodesk. And this drives smarter decisions and improves project outcomes ultimately. It obviously begins in the planning phase, moves into the design phase, continues as the project moves into the construction or delivery phase, and then we speak to the owner-operators who are tasked with the ongoing maintenance management of these new assets. So today we're going to explore how components of the ArcGIS system by Esri support the use and reuse of CAD and BIM content created and curated within Autodesk, as Stephan's showcased just now. You'll see how the ArcGIS system leverages a modern web services oriented architecture to connect users to WebGIS through either ArcGIS Online or ArcGIS Enterprise in order to access your project data, as well as services from other agencies through native desktop, web, and mobile applications. As we've heard already, since 2017, Esri and Autodesk have had an alliance which has brought forward a number of integrations between GIS and traditional CAD and BIM processes. So a couple of examples are the Autodesk connector for ArcGIS, which brings content from ArcGIS Online and Enterprise within Civil 3D and Infraworks, as we've seen today. But beyond that, we've got some more recent supported patterns to be able to directly read content from Revit, Civil CAD from Civil 3D, and more recently, connecting to cloud repositories and the likes of BIM 360. So let's now take a look at these types of tools and how you might use them throughout the plan phase of your project. Typically, the first question that gets asked during this planning phase is, where can I access data? And it is estimated that during the planning phase, engineers can spend up to 40% of their time just looking for relevant data to inform their project or site. A good example of this built into the ArcGIS system is the Living Atlas of the world. This is an example of a treasure trove of authoritative content, both curated by Esri, as well as a range of local, state, and federal agencies that you can search for items within ArcGIS, as well as within the Living Atlas pane using the Autodesk connectors. Beyond the global Living Atlas, there are many local examples, such as the Spatial Services in New South Wales, their new spatial collaboration portal, which has been launched by the Department of Customer Service. Within this portal, users can actually search for authoritative foundational spatial data, as well as 2D property information, which is a common input to inform designs, as well as 3D layers, such as the BIM model for a train station on the bottom left out in Western Sydney. ArcGIS for AutoCAD is an Esri plugin that's freely available that enables you to connect to your ArcGIS Online or ArcGIS Enterprise and consume content, be it publicly shared from state agencies like Spatial Services, or within your own organization as far as secure layers that have been privately shared just to groups that you're collaborating with members, be it your GIS team, your CAD team, or your BIM modelers, or all and sundry. So during the design phase, the goal was really to develop a complete solution with respect to form and function that fulfills your project's program. And now we're going to look at some examples of that pattern where we can connect design content inside of the ArcGIS system. So our desktop tool that's commonly used, known as ArcGIS Pro, offers the ability now to not only directly read CAD and BIM content, be it DWG files or Revit models, but we can actually now support cloud connections to Autodesk Construction Cloud and BIM 360. So you can see here we've got our BIM 360 pane, and that repository has all our managed and versioned BIM and CAD content that we can actually connect to inside of ArcGIS Pro and consume that in Pro and publish it up to WebGIS portals such as ArcGIS Online or ArcGIS Enterprise. So you can see here by creating a cloud connection to BIM 360, authenticating against my identity from the Autodesk side, and this enables me to access content that's being shared with me within BIM 360, such as the design information as it's connected here on our catalog pane. If you think about what this supports is really gone are the days of ETL or extract, transform, and load processes. We can now directly connect to the source of truth and have the BIM 360 instance manage the versions associated with changes to CAD or BIM models, which is really great outcome from an efficiency on projects perspective. Another good example is how do we scale this beyond just one single building? We can, through new tools available in ArcGIS Pro, such as the BIM file to geodatabase. What we're seeing on screen here depicted is more than 80 buildings across a university campus in North America, representing about 1 million individual BIM elements from respective BIM models curated inside of Revit. So now we can actually consume multiple BIM models using these built-in tools and publish those out into experiences for our users, such as the web scene viewer built into ArcGIS Online and Enterprise, which offers a building exploration capability. We're seeing toggled on and off in the window now. Another important addition we saw before, consuming GIS content inside of Civil 3D. The inverse, we can actually, in a similar pattern, connect to BIM 360 or directly to Civil CAD, bring that data in to inform our network information models and bring those inside of ArcGIS Pro to curate with other contextual data and layers, which is a great outcome. Wanted to share briefly a project here in Sydney, the Circular Key Renewal, and just some insights on how they've adopted some of those patterns for this particular project. And if you want to find out more in other case studies, by all means, scan the QR code and access our Geo Bim content on our website. So the scope of this was to scan the entire precinct beyond just the wharfs themselves, to curate a federated model or models, including geotechnical survey, and this needed to be surfaced inside of a federated experience, or what's known as the asset information model. So the process was very similar to what I mentioned before, directly reading in that CAD and BIM content, be it IFC or Revit, which we both now support, bring that into ArcGIS Pro to then publish out as layers inside the GIS to be consumed inside of the asset information model via the web scene that we've just seen from the university campus. So essentially the asset information model offered linkages out from model elements beyond just the geometry itself. So really that connected notion of using this asset information model from ArcGIS to launch out to other information environments, be it a document management, be it a drawing management solution, is really a common pattern we're starting to see nowadays. So within Revit, here's a look at the precinct, where the process of using recap from Autodesk to actually assist the modelers inside of Revit to develop up a series of Revit models. And the same model brought into ArcGIS. So we're seeing depicted here the geotechnical surfaces, including sandstone and the like. And this enables us to get that cumulative view of not just the urban environment, but also the surrounding contextual layers. And the asset information model, which was a web application or experience, is used nowadays. So the project was supported through Norman Disney Young, part of Tetra Tech Group. And you can see here some examples, the ability to bring in asset information attributed from the underlying Revit model for the heritage rail, and likewise launch links out. So offering the people to launch from the asset information model inside of GIS out to reports and studies that may have been curated. At the build phase, Esri brings a better way to work by preparing and executing against project plans. So we support this in a multitude of modes, including field data capture workflows and drone data capture workflows. So some of you may have heard of ArcGIS field maps. Field maps is the next generation of former applications like Explorer or Collector you may have heard of. And this enables us to bring CAD and BIM content to view, as well as capture data about maybe safety incidents, condition assessments on site, as we're seeing these points features on the map here. And with that field mobility, because the ArcGIS system is built on the web services architecture, we can surface those services and layers inside of experiences like this construction status dashboard, where we're actually seeing the floor plan from CAD, and we can actually then see data that's been captured from some field mobility apps like Field Maps, which are those site inspection reports or permanent inspection reports. And just a very quick note to suggest that beyond field data capture, we're seeing increasingly the uptake of drones, and recently Esri have acquired a company and formed a site scan for ArcGIS as offering a complete end-to-end flight planning, processing and data sharing solution, including, importantly, the ability to share out information products, be it a surface, elevation model, contours, back to BIM 360. So this is a supported pattern built into site scan. And here's just a very quick example of a different view by curating all those epochs of drone flights, drone imagery, but also seeing it in context with photo mesh from the drone, plus our BIM model that's originated from Revit. And we can actually surface that there to look at cost, time, and schedule, and perhaps compare how the construction project is progressing against plan. And lastly, the operate phase. Typically, this is a longer life cycle. We see the adoption of GIS for the ongoing maintenance management of both physical, but also these new digital assets that we're starting to hand over. So a really good tangible example of that is ArcGIS Indoors, which is an indoor GIS for asset space and building management. We can reuse CAD and BIM content inside here and support, importantly, the ability for users to wayfind to particular assets, be it a room, be it a feature, points of interest, a hydrant across a single building, or in this case, across an entire campus. So we can support that wayfinding both through a web experience and a native mobile app. So we've seen that a better way to win work, do work, forms against these four pillars that Stephan's also spoken about. And this is really culminating in a new solution from Esri. So today we've spoken about, dedicated software for traditional CAD and BIM managers or modelers and GIS professionals. But these clients are requires skilled staff to operate. And we've seen how we can, through web services, bring data and content to and from each of these respective systems. But this is still reliant on trained professional skilled workforce. So Arcgis Geo Bim, which launched this week, brings content together from both Arcgis and the Autodesk Construction Cloud, or BIM 360, and it places your project and information on a map in a seamless web experience. It really transforms how you might go about your projects with geospatial context and the BIM and CAD content. So here's a look at the Arcgis Geo Bim Experience. So I can click on GIS features within this Arcgis Geo Bim, and we can see here I can launch the associated content within our Construction Cloud from Autodesk or BIM 360 or Autodesk Docs. So here we're referencing the latest version of that model relevant to the 2D geometry we have depicted on the GIS portion of Geo Bim. So here we're now looking at that floor plan we saw before when we were doing our construction site progress and the build phase. And we've got the photo mesh brought in similar to how we demonstrated with the drone example before. We can also add links outside to not just geometry inside of Autodesk, but through Autodesk Docs, we can reference and refer to maybe manufacturer or reports that might reside in that repository. And the cloud-to-cloud connections enable us to click on model features in the GIS component and view those inside of the BIM 360 Forge viewer we're seeing on the right-hand pane. So in the past, this would have been separate apps and separate experiences. So it's really great to bring the two together. So hopefully you can see both from our presentation and Stephan's earlier that this connected data environment through web services is really going to bring great efficiency and benefits to your projects, none more so than Arcgis Geo Bim, which attends to any phase of your project or asset lifecycle. How do you get started? Obviously, you need Autodesk Construction Cloud or BIM 360 to be a candidate to take this up. And from an Esri or ArcGIS side, users of ArcGIS Online would have seen Arcgis Geo Bim user types appear in their organization accounts this week if they have the appropriate licensing level. So on that note, thank you for your time, and I'll hand back now to Anton.
Great, thank you, Seth. That was fantastic. So yes, we've got a few questions coming through, and thank you for those. We'll get to as many of those as we can, but if we can't, we will definitely get answers back to you through our presenters in the next week. I might just start with just some questions about licensing. Seth, you did actually just touch on some of these things there. So the licensing, you require both ArcGIS and Autodesk licensing. Can you maybe just give a quick overview again of how the licensing works?
Sure thing. Thanks, Anton. So as I mentioned, for any ArcGIS users with either a GIS professional user type, standard or advanced, there's no change. You'll automatically see those user types appear in your account in coming days. And on the Autodesk side, you just need to bring and have an Autodesk identity subscribing to Construction Cloud, BIM 360 or Docs. Yeah, you do need both in order to be a candidate to use Arcgis Geo Bim.
Great. And when is there any kind of timeline on when they will these things will be available?
Yeah, sure. So obviously Autodesk University is occurring this week, and the Arcgis Geo Bim launched earlier this week. So no doubt we'll see more from both Esri and Autodesk alike relating to Arcgis Geo Bim. If you want to deeper dive on GeoBim, obviously we didn't have much time today, but happy to speak to people in due course. Yeah.
Yep. Right. What about availability in ArcGIS Enterprise?
Yeah, sure. This is a common request, and it is on the product roadmap as far as a plan to support ArcGIS Enterprise in 2022. So the product team are currently working on that, and we're after candidates to potentially assist with informing the ArcGIS Enterprise support. So if you are one of those clients, please reach out to us, and we can have a conversation about that in due course.
Fantastic. Okay. Now we've got a couple of questions around how coordinate systems and datums are referenced. So many projects are being built in custom or local grid coordinate systems. How does GeoBim handle that?
Yeah, it's a really good question, and none more so because there's quite a transformation occurring in Australia, especially with GDA 2020. So we're seeing many projects adopting that as a spatial reference, including Snowy 2 is one example. It is a extension of ArcGIS Online. It's in the first rendition, so any of the supported spatial reference or coordinate systems available there will be supported. And another thing that's built into ArcGIS GeoBim is a common occurrence is sometimes CAD or BIM content inside of BIM 360 or Construction Cloud has no spatial reference. So there's an actual georeference portion to ArcGIS GeoBim to spatially locate with the correct reference system, as Stephan demonstrated earlier, to place that on Earth so we can have that contextual cumulative view. Otherwise, it's no good sitting off the coast of Africa on coordinate 00. So hopefully that provides some context.
Terrific, thank you. Let me see, we've got some questions around just integrations. So how does this tie in with asset management systems such as SAP?
Yeah, sure, I can take that one. The virtue of the modernization of the ArcGIS system and orientating to become services led leads itself to the associated APIs. And what we're seeing is this connected data environment can be connected outside of connections to Autodesk to other systems using the APIs available. So at the back end of GeoBim and the back end of ArcGIS, a bunch of RESTful APIs that can enable connections to other systems like SAP to maybe generate a work order, or vice versa, maybe to visualize a work order inside of ArcGIS.
Okay, fantastic. Sorry, Seth, there's probably a number of questions that are perhaps more aimed at you than Stephan, so apologies about that. So just again on the integration question, so given that GIS needs to integrate into EAM systems for maintenance requirements, how does Esri ensure that the BIM data brought into ArcGIS is aligned with the asset management requirements of the asset register, etc.?
Yeah, it's a really good question, and I think we've got some great examples both locally, we are based in New South Wales and interstate in Queensland and Victoria and the likes. That is looking at like the standardization of the asset information that's required in all phases of the project or asset lifecycle, and trying to avoid the information loss in the project handover, which, you know, in the past has been a blue hard drive, and we can see now through web services we've got unique new ways to offer that, not just at the end of the project completion, but throughout the project lifecycle to upstream clients. Yeah, so we support that in a few ways. I guess a tangible example of that is evident in the ability to create connections to cloud repositories like Bim 360 that manage the master data for the latest version of the CAD or Bim content, especially in the plan design, but also the build phase. But obviously in the operate phase, those changes are kind of set in stone, and we have the final kind of physical and digital version of that asset. So we can support that and validate it inside of ArcGIS. There's a number of tools to review data, do checks against geometry and checks against the attribution to make sure that that's fully populated, and people are doing condition assessments that updating the correct fields, that kind of thing. But maybe that's one we can talk offline. So I don't know who that was asked by, but it's a really good question. So thanks for posing that.
Great. And another one on integration. You say that ETL type interfaces are replaced by direct connections. How does this work when the BIM data doesn't align with operational data requirements from other integrated systems like EAM and ERP?
Yeah, that one maybe we can take offline and discuss, because it's really a dependency on the phase of the project. So when we're talking about the asset management workflows, they're quite unique and different to earlier phases in a project or asset lifecycle. So yeah, happy to maybe we can take that one offline and follow up with that question. But yeah, another great question.
Yeah, no worries. Let me just see. There is some other questions, let me see, around IP. What functionality has been built into this partnership to protect the IP of the customer and the designer's information? For example, if the designer wanted to access the customer's information, but it was protected by the IP, is there a password gate of sort to protect the access between collaborators? This might be perhaps, Stephan, you might have something to say here too.
I don't have anything specific to add, but I mean, the purpose of this collaboration is that everyone is actually working together on the project, right? So I'd like to think that the IP of the previous design, let's say, would be, I guess, handed over during that project design regardless, right? Maybe not the specific CAD model originally or the BIM model, let's say, but you would like to think that at least if you were, let's say, widening a road or putting some new services underground, those existing services or the existing road design should be shared with the new designer as well. So I think it might be worth a follow-up on that one as well.
Yeah, from an ArcGIS or Esri perspective, there's a really good resource in trust.arcgis.com, and in it you'll note some resources around IP and Esri's stance on that, which is we protect your IP in perpetuity. But yeah, trusted.arcgis.com is a really good resource to go to find and some kind of common answers to those FAQs. But yeah, we'll put those together on the back of this event as well as a link for those that may have not got that down.
Yep. Fantastic, thank you. So we are coming towards the end of our session, and I know there's a lot more questions that we haven't got to during this time, and we will endeavour to get answers back to all of you in due course. But just before we finish, we did want to just have a quick poll just with the audience to respond, which you should see on the screen presently. But both Autodesk and Esri Australia are available for further one-on-one discussions so that you can discover more about what this means for you. And so we want to know if you would like us to get in touch, and then we can pick those conversations up for some more detailed discussion. So if you could maybe just respond and let us know just in the poll, and that would be fantastic help for us. In the meantime, if you want to explore more, just head over to Autodesk or Esri Australia's websites. We have use cases and white papers, industry thought leadership, and technical applications of the content we've shown here today. And I'd also encourage any of you to get in touch if you have other webinar topics you'd like us to cover in the future. So please let us know your feedback. So just this brings us to the end of our session today. So thank you again for joining us, and we appreciate your participation and your questions, and we will look forward to talking more with you about with these things in the future. So thank you very much for today.
Thank you.